So in this lecture we are doing few problems based on the motion in a vertical plane. Okay, let's see this problem. So look at the first problem. It says calculate the following following things for the given situation. So you can see I wrote in shortcut. So there is they said that there is a frictionless track and a body sliding on this, then enter in a circular loop. Okay, then you have to calculate speed of this body at this point. You have to calculate this height h, whatever height, and normal reaction at what d point, and few things given. The velocity at this point is given. Okay, c point given, right? Okay, this was a point A, B and C, D. So this slide from a height h, okay, comes here, enters the loop, and we have to calculate few things now. Okay, so two rules we use. First you see is a vertical circle, the body is moving in a vertical circle, and we use conservation of energy. Okay, okay, look here. First what we know velocity at this point, correct? Velocity of this point we know, radius we know. So let's calculate for this height. Let's calculate the B answer first. Okay, so what I am doing, I am writing what conservation, by writing conservation of mechanical energy. I am writing at what point? At point A and point C. At this point and that point I am writing conservation of energy. Conservation of mechanical energy, we are writing point A should be equal to what? Mechanical energy at point what? C. This is the principle I am writing first. Okay, so let's write it. At that point what energy you have? Only potential energy, right? Is at rest. So at that point you have potential energy. That's what m, g and h. M is the mass of that body. Okay, height h. So when we come, that body come at this point is moving, so it has kinetic energy plus it has some height from the ground, this much height. That will be simply the radius of this loop only, again r, that's the height, right? No? So it has kinetic energy plus potential energy both. Look here, so at this point, this at energy at point A we said no problem. Now what's the energy at point B? So I am writing what is the potential energy, m, g and h means what? That much r. This is the potential energy plus kinetic energy, which is what? Half mv square. Half mass is m, velocity means this is the velocity given, root 7 gr they have gave already. Okay, so it becomes 7 gr v square. Okay, yes. So we have to calculate, like height we are calculating in terms of radius of this loop. So it's okay. Look here, mgh is equal to this mgr, and that becomes 7 by 2 of mgr, right? If you simplify this term, mgr plus 7 by 2 mgr, this becomes 2 plus 9 means 9 by 2 of mgr, right? So you see mg can cancel on both sides. So h is simply coming 4.5 times of the radius of this loop. So that's the height. Okay. Yeah. Another question we'll see where the opposite question will be there. We'll do it later. So look at this problem first. So this is the answer of what? Your height. We done this. Then next they are asking the speed at D point. We can calculate speed at this point. Yes, we can calculate, right? So let's answer that question. What is speed at any point? Okay. So again we can write conservation of energy only. So look here, energy at this point we know at this point. So you can write any point, your choice, because mechanical energy is always conserved, right now. And this conservation of mechanical energy mainly we will learning in what? Next chapter, work energy power. Okay. Yeah. So physics is interlinked. So concept from here there comes together always. Okay. So let's answer that question, that what is the speed at D point. So you can write conservation of energy at any 2 point. I can write that mechanical energy at point A should be equal to mechanical energy at point D. You can write this, or you can write mechanical energy at point C should be equal to what at D. Any point you can write, it should be always same. So what is the mechanical energy? I am writing this equation. Suppose mechanical energy at point A is what? mgh. Mg and h already we know what? 4.5 into r should be equal to what? Mechanical energy at that point, right? Now at that point is moving, so again it has kinetic energy plus potential energy. So what is the energy at D point? Its height is what? From ground is what? R plus r means 2r. So potential energy will be what? mg and 2r plus half mv, let's call v d square. This we have to find, velocity we have to find at that point. Okay. So let's write it carefully. This becomes 4.5 of mgr is equal to, this becomes 2 mgr plus half mv square. Okay, this term come on this side, so it will become 2.5. So this will be 2.5 mgr is equal to what? Half mv square. Goes here, 2 comes here, so v is coming simply root 5 gr. That's your answer. So velocity at D point, what we are calling point D. that will be what? Root 5 gr. At any point you can calculate. Suppose they ask velocity at B point, you write energy at this point mgh is equal to what? Just half mv square here, that's all. This is at this point we don't have potential energy because this is at ground point. At this point we have potential plus kinetic, at this point also you have potential plus kinetic, right now. So you can write conservation of energy simply. Okay. Then what else? One more question is there, something speed we have calculated. They are asking what is the normal reaction at point D? What is the normal reaction? So normal reaction is force, right? So we have to write force equation at this point. What force are acting on this body when the body is what? Here. Okay. Yes. Look here. Centripetal force mv square by what? R. mg is what? Downward, right? And normal reaction is what? Like this way. Normal is always perpendicular surface. So here like this way, right now. Do not confuse. Suppose you put a body on ground, then mg will be downward, normal reaction will be upward like this one. But it's like that way. You are at this point, you have vertical circle and you are at the top of this vertical circle. So mg will be downward and normal reaction also looks what? Downward like this one. Centripetal force will be what? Outward, right? So look at that equation. In that equation what happening? You say that mv square by r is equal to what? Mg plus what? Normal reaction, and I have to calculate normal reaction. So normal reaction will be simply mv square by r minus what? Mg. Velocity at that point already we have calculated at D point. So how much that came? This much. So if you put the value here, so this become m into 5 gr become 5 mg, because r get cancelled, minus what? Mg. So it's becoming 4 mg. Let's check it. V value I am putting here, value velocity at D point already calculated, root 5 gr, you put it here. Okay. So r get cancelled, you are getting 5 mg minus, so mg is what? 4 mg. This is the answer of the first question. Okay. Very interesting. One more question you have like this, will do. Look at the second problem now. A stone of mass 1 kg is tied with a string of length 1 meter. Okay. Yes. Is wheeled in a vertical circle. If the velocity at the top point is 4 meter per second, velocity at top point is given, find the tension at the top point. Velocity is given, we have to find what? Tension. So this is your vertical circle, at this point they are talking, right? So velocity is given at that point and they are asking tension. This is tied with a string, correct no? Yes. Okay. So look here, what force are acting? Mg force you say downward, tension force T is what? Downward, and your mv square by r is what? Upward, correct now. So you say that T is equal, okay, T plus mg is equal to what? Mv square by r. We have to find tension. So tension simply T is equal to what? Mv square by r minus what? Mg. So when you put the values here, velocity already we know. How much we know? Mass given 1 kg, length given 1 meter, and velocity is given what? At top point is given 4 meter per second. Let's put all the values. Okay. So mass is given 1 kg, velocity is given 4, becomes what? 16, by radius given what? 1. Length of the string is simply radius. Mass again given what? 1, g is given 10. So this becomes 16 minus 10 means simply what? 6 Newton is your answer. Correct? Simple. So at any point you can calculate velocity, tension, and I told you general formula also to calculate tension here, right? Suppose you don't want to write the equation like this way, you can write a direct formula also, right? Okay. Then let's move to third problem. So a stone of mass 0.2 kg is tied to a string of length 0.1 meter. Okay. It is wheeled again in vertical circle. If at the lowest point they are talking, the tension the string is 52 Newton, then the velocity of the stone at this point will be what? So this question is just opposite of that question. Here velocity was given and they are asking tension, here tension is given, they are asking velocity, but lowest point. So same picture only I am drawing, this is the lowest point. Let's write at lowest point what happening. Look here, mg is straight downward, tension T will be upward, and centripetal force always what? Mv square like this way. Okay. Yes. So tension at this point will be simply mv square by r plus what? Mg. If you are confused this how to write equation, I told you direct general formula also you can write. What you can write always general formula like this way. Tension is equal to what? Mv square by r plus mg cos theta. This is general formula. At any point you can write. This angle always we measure with respect to what? This line. Okay, like this line, this is angle theta. Okay, so we are talking lowest point, so angle is what? 0 degree. So this answer will come. In last question we are talking about this point, so angle is what? 180 degree. When you put cos 180, this become what? That equation. This equation, this become negative, right? So this is general formula. Okay, let's solve this. They are asking us velocity. Tension is given what, 52 Newton, okay, given, I put it here. Mass is given what, 0.2, length is given 0.1. 0.2 by 0.1 become 2, so 2v square plus mg. M is given what, 0.1 into what, 10. No problem. So correct only, sorry, plus, okay, nothing wrong. So once more, if I did something wrong, look here, tension is given 52 Newton, yes, 52 only given, and mv square by r, mass is given how much, 0.2 kg into v square by length is given 0.1. So this become what, simply 2, 0.2 by 0.1 is what, 2 v square, mass is given again 0. Here I did mistake, mass is given 0.2 actually, okay, yes, into what, g. Okay, so this becomes 52 minus 2 means 50 is equal to 2 v square. So simply v becomes what, 5 meter per second. Okay, because 50 by 2 is what, 25, and root becomes what, 5. So that will be the velocity at the lowest point in this circle, right? Okay. Okay, let's move to the last problem. It says that similar to that type of problem, that a body slide down a frictionless track and which ends in a circular loop as shown in the figure. Okay, calculate the maximum value of radius. Radius you have to calculate for the body to successfully complete the loop. Here height is given to you. Height is given and they are asking radius. Now tell me, we have learned that if you want to make a complete loop, then what conditions we need, what velocities we need at different points. So hope you remember, at lowest point need minimum velocity is what, root 5 gr, correct? No? At this point we need what, root 3 gr, and at this point we need what, root gr. So again you have to write conservation of energy only at this point to that point, or this point to that point, your choice, you can write at any point. Because to make a complete loop, we know velocities we need. At this point should be root, minimum velocity should be root 5 gr, at that point should be root 3 gr, at that point should be what, root gr. So velocities we know already actually to make a complete loop. So you can write conservation of energy. So it's your choice where you are writing. So suppose this point you are calling what point? I wrote A, B, C here, you can D point something, okay. So conservation of energy you are writing, mechanical energy at D point should be equal to what, mechanical energy at what, A point, that's simplest. Why I am writing this point, because this point is very simple. Here we have only kinetic energy. If you choose this point and that point, here we have kinetic plus potential both. At this point also we have kinetic plus potential both. So simple is what, this point. Okay, look, what is the energy at this point? Only potential mgh is equal to, at this point we have only what, kinetic half m, let's call V a square, right? Okay, m directly goes, g means what, 10, and height is given to us already what, 5 centimeter. So 5 into 10 power minus 2 centimeter is what, not SI system, I am writing in SI system, is equal to 1 by 2 into what, okay. One more thing you have to see, suppose I calculate it this way, then this velocity also I know already, right? So I have to calculate actually r. They are asking calculate the radius, where it says calculate r. Suppose you write conservation of energy here, then you will not get r term actually here, right? Radius is not coming. So there is no use of this, okay. So I have to rub this, and what I have to write? I have to write some point where r is coming. Suppose you can write this point or this point, here r will come because potential energy will come in terms of r. Yes. So here you cannot write because here r term will not come in this. Okay, writing is okay, there is no problem, but r will not come here. Velocity already we know, height also we know, so nothing is unknown here actually, okay. So what you do, you can write this point, then you can write this point or that point, your choice. So let's write, suppose I am writing C point, okay. Now look what will happen. So here mgh, okay, mgh is here, at this point we have kinetic energy half mv c square plus potential mg, and height is what, r simply, that's all, okay. Again, now mass we cancel everywhere, g. So g is how much, 10 into height is now what, 5 into 10 power minus 2 is equal to half, and velocity at this point is velocity already you know what, root 3 gr. So it becomes simply 3 gr plus what, g into what, r, okay. So if you simplify this, look here, this is what, 1.5 gr, this is what, 2 gr. So this becomes what, 2.5 g into what, r, correct, okay. And g also you can cancel on both sides because no need to put this g value, g is also same. So this 2.5 goes here, what we will getting, r will be simply equal to 5 into 2.5 into 10 power minus 2. Suppose this is what we wrote this because we are writing answer in centimeter to meter. So this also simply tell you what centimeter only. So 5 into 2.5, how much it becomes? 5 into 2 is what? 10. So it becomes 12.5 into 10 power minus 2 meter, or simple answer is what? 12.5 centimeter. That is your answer simply. You should get exactly same answer. If you write energy conservation at this point and this point, you should get exactly same answer. Keep in mind, okay. mgh at this point is equal to what? Here potential is what? mg, and height is what? 2r, plus kinetic is what? Half mv square. This is the velocity root gr. Should get exactly same answer, okay. Okay, so these are 4 questions, and let's do few more problems because this topic is very important for us, okay. Okay, let's see few more problems on motion in vertical plane, okay. Look at the 5th problem. A mass tied to a string moves in a vertical circle as shown in the figure. If string breaks at point P, then the mass will rise to a height what? Look at the question. We are moving in a vertical circle, clockwise or anti-clockwise, like that way. At this point, the saying string breaks. When it's about horizontal, okay. When the string is horizontal, the string breaks. So they said radius of this string is given, length of the string, and at this point velocity is also given 5 meter per second. When you break the string, break at this point, it will rise to some height, the stone will rise to some height, that height. So this height we have to calculate how much height it will rise, correct. It's just like what? You are throwing a stone straight what? Upward with some initial velocity, right now. So what you can do, you can write equation of motion also here, or you can write what? Conservation of energy. Conservation of energy is very simple. At this point, suppose this is a reference level, okay. At this point you have what? Some initial kinetic energy, and at that point kinetic energy is 0, the body stops, so we have potential energy. So again we are writing conservation of energy. At this point energy is what? Half mv square. At that point we have what? Potential mgh. So h is unknown, that we can calculate, okay. Mass cancel here, half, velocity is what? 25 is equal to g into what? H. So this becomes 2.5, so h becomes how much? 2.5 by 2 means 1.25 meter. The stone will rise what? 1.2 meter height. Same question was asked in another way, like this way. Suppose same string is rotating like this one, I say clockwise or right, whatever, and like suppose the string break at this point or that point, okay. We say moving like clockwise, moving like this way, let's say clockwise. If it break at this point, it will move upward. Breaks at this point, it will move what? Downward, correct na? So you can calculate velocity and whatever they ask. But suppose the string breaks at this point, right? At the top point the string breaks, then the stone will move like that way. This is called a parabolic path. What is called? Parabolic path. So in our 2nd chapter, motion chapter, we learned like projectile motion. For the people who viewing this video on YouTube, I have not taught that topic yet. So this is called a projectile motion. I will teach that topic very soon. So this is called a projectile motion. It will move like a parabolic path. Here it will move in a straight path, okay. If it breaks in what? Horizontal position, like this way, okay. Okay, it moving anti-clockwise means it will break at this point, move straight up. If it's moving clockwise, then we will break at this point, it will move what? Straight up, right? Yeah. So it moves in parabolic. Then they ask you what is that distance, horizontal distance, x. This is called simply range actually, okay. So this way also it can break, and here you have to find range, where it will fall, at what distance fall from this point of projection, okay. Yes. So here what we do, we apply the concept of what? Projectile motion. Projectile motion, we calculate range. This is called range, and range formula is what? Simply the velocity into what? Time, u into t. Velocity is u only, and time is called what? 2h by what? G. Means what is the velocity here? Whatever velocity at this point. At this point you need to calculate velocity, that you will put what? Here. Height means what? That height, r and r. So you will put here 2r. You will calculate your answer using this formula, okay. Yeah, if you see somewhere this type of question, please do using like this. Okay, so let's move to 2nd problem. It says a particle moves in a vertical plane as shown in the figure. At what point will have, okay, figure was like this one. So this thing, particle is moving in a vertical circle like clockwise, anti-clockwise, and some points were given. Let's say point A, that you call point B, point C, and point D. Then question was like this one, that at what point it will have the maximum possibility of what? Breaking the string. At what time or at what point the string breaking possibility will what? Maximum. So string will break when the tension is what more than that string can hold right now. So at the point where the tension is maximum, at that point we have the more breaking possibility right now. So you know that among these 4 points, at what point we have maximum tension? So what is the answer at this point? This is the point when tension is what maximum, this is the point tension is what minimum, because you know formula tension is what mv square by r plus mg cos theta, general formula like this one. So in this formula this will be maximum when cos theta is what 0, means at this point you talk, because angle will be measured with respect to what this line, keep in mind. Suppose you are here, that's your theta, you are here, then that's your theta. So with respect to what this line we measure always angle. So when you are at the lowest point, the tension in the string is what maximum. So string will break at what this point is breaking, right. So this point has the maximum possibility of what breaking the string, because at this point the tension is what maximum, lowest point. Okay, okay, let's see next problem. A pendulum has a speed of 3 meter per second while passing through the lowest point. So at lowest point the speed of this is given, right. Okay, calculate the speed when the string makes 60-degree angle to what vertical if the length of string is given 0.5 meter. Okay, let's draw the picture. So some circle is given and the said a velocity at this point is given, this is called lowest point. How much given? 3 meter per second, here given 3 meter per second. Then they saying a length of string also given 0.5 meter string. Then they say when it's make an angle of some angle, how much angle? 60-degree with what vertical. So this angle is given 60-degree. Then they asking that at this point what is the speed? Okay, at this point you have to calculate speed. So look here, there are many ways to calculate. At this point, suppose this is a height of how much height? That height from the ground, this is the height h. So one way is to calculate what? By writing conservation of energy. Energy at this point should be equal to energy at that point. At this point we have only kinetic energy, but at this point we have potential plus kinetic both, right? Yeah. So we have height, we can calculate this because in conservation of momentum topic I told you that how to calculate height, how much string rises, right, in terms of what length of the string and the angle. So that formula was like this one, h was equal to L1 minus cos theta, if you remember. This was the formula to calculate height if you know the angle, or to calculate angle if you know the height. So height we have to calculate. What is the answer? L is given 0.5 meter, 1 minus cos of what 60, and cos 60 is nothing but what 1 minus what 1 by 2. So this becomes 0.5 into what 1 by 2, or you can write this answer as 1 by 4 or 0.25, your choice. This is what your height, first thing. Okay, okay, this is your height you calculated. Now you write the, because you have to find velocity at this point, so let's write conservation of energy. This point is A, that's point B. So energy at that point A should be equal to energy at point what B. So you write like a mechanical energy at point A should be equal to what? Mechanical energy at point B. So what is energy at this point? Only we have kinetic energy. So half mv square, half mv square means what? 9. Mass we don't know, it will get cancelled on both sides automatically. Okay. So at this point we have what? Only kinetic energy, half mv square, half m, velocity is 3 square. At this point we have kinetic plus potential. Kinetic will be half mv square, which you have to calculate, plus potential is what? mgh. mg means what? 10, and h already we calculated what? 0.25, correct. So mass get cancelled everywhere, no problem. This is what? Simply 4.5 is equal to what? 1 by 2 v square, and this become 10 into what? 0.25 means simply 2.5. 2.5 goes this term, so this becomes simply what? 2 is equal to 1 by v square, or 2 goes here 4. So v becomes what? Simply 2 meter per second. So this is the velocity of this particle at that point. I wrote simply by conservation of the energy, right? Yes. So I need to calculate height here. This is a height formula in terms of angle, right? We have done already. So you should be able to do this, right? Okay. Let's move to the next question, question number 8. It says the a thread can bear maximum tension up to what? 30 Newton. The maximum tension it can have is what? 30 Newton, and maximum tension we just have learned that it happens always at lowest point, right? If a stone of mass 0.5 kg is tied and rotated in vertical plane, find the maximum angular velocity if the length of string is what? 2 meter. They are asking what is the maximum angular velocity? Omega we have to calculate. To calculate omega, first we need what? V. Okay, because we know simple relation that V is omega is also equal to simply V by what? Radius of the circle, right? So we calculate V linear velocity, then we can calculate what? And they are asking maximum angular velocity. Maximum velocity happens what? At the lowest point, again we know right now. tension also maximum, velocity also maximum at this point. So look at this, at lowest point few data are given to you. At this point they are talking. So what is given? Tension given. We know tension at lowest point is what? Simply mv square by r plus what? Simply mg cos theta, means cos 0 means just mg. Okay, look here, tension is given to already. How much given? 30. Okay, mass given? Yes, mass is given 0.5 and radius also given, right? Okay, 0.5 v square by radius also given to what? You 2 meter plus mg. So m is 0.5 and g is what? 10. Correct. Okay, this become 5 goes other side, this become 25 and okay, let me write, we confuse. So 25 and this 2 comes here, so it becomes 50 is equal to 0.5 into what? V square. No problem. Okay, so this goes here, so this becomes V square becomes simply 100, so V becomes what? Your 10 meter per second, right? So at this much tension they are talking about maximum tension, means they are talking about the lowest point. Also they are asking the maximum angular velocity. So this is all your linear velocity we have calculated already. Okay, now we need what? Angular velocity. So this is the relation, simply we have omega is what? Simply v by what? R. Linear by radius, linear given 10 and radius already we know is what? 2 meter, right now. Yes, so this becomes what? Simply 5 unit, you know, that is what? Radian per second. That's the unit of the angular velocity. Suppose you don't want to do here itself, you can do this formula also, you can write like in this simple formula, omega square into r also you can write now. Correct na? Yes, sorry, m omega square r, like this you can write directly, you can calculate, that's your choice, but it's a simple procedure already we know like this. Okay, okay, let's move to the last question. It says that, very important, it says the mass m is tied at the end of a rod of length L. What is the minimum velocity at the bottom point required to make a complete loop? Before I answer it, pause the video and you answer this. What should be the answer for this question? It's very simple. Hope you answered. So if you are saying your answer is root 5 gr, then it's wrong answer. If you said that the minimum velocity required at this point to make a complete loop, bottom point is root 5 gr, then that's a wrong answer for this question. Why wrong answer? Because question is saying is a rod, not a string. So far what we have done is all are what? String. So in theory also I told you a special case, at the end we will talk about rod. Suppose this is not a string. String is what? Flexible always, right? But rod is what? Not flexible. Rod is always straight like this one. So rod is a different case. And if they talk rod, please highlight this rod, correct na? For rod, the velocity at lowest point to make a complete loop will be simply just root 4 gr only, not 5 gr. Answer of this question is what? Root 4 gr. String which are negligible mass and flexible, you know, right now. For them the velocity at lowest point to make a complete loop will be what? Root 5 gr. But if the same question they talk about rod, then this become what? Root 4 gr. Be careful about that. Okay. Okay, so now what we are doing, we are quickly revising our the complete circular motion chapter. We have already done it, so let's quickly revise this in 2 minutes. Okay, so what you have learned here, the starting first you have learned the equation of motion, how it moves. So the linear equation which you have know, that same you wrote in terms of what? Angular motion. So first you learn about what? Motion, right now. So you wrote in terms of angular form, like omega is equal to omega naught alpha into t. That's the first equation of motion. Then you wrote like theta is equal to what? Omega naught t plus half alpha into t square. You wrote third equation like omega square minus omega naught square to alpha into theta, where omega is called, like omega naught is called your initial velocity and omega is called your final velocity. That's called angular acceleration. All the relation also we have discussed, like how you write. You say linear velocity is equal to what? You wrote like omega cross what? R, right? In simple language, right? Same you wrote like angular so linear acceleration A is what? Simply you say that angular acceleration we call it alpha cross what? R, right? Vector form, right? Yes. And once you wrote these questions, you have solved the like similar question what you do in linear chapter, exactly we have to do it here. Then here one more question they ask, like number of rotations made by a some moving body. Okay, so number of rotations suppose they ask, then I told you number of rotations. Okay, that is simply what? Total angle covered, which you can call like total angle covered theta by what? 2 pi. This gives what? Number of the rotations, right? Yes. Here when they asking these questions on this, they never gives like angular velocity directly, they always gives what frequency. So the frequency they can give like they can give in terms of rps, revolutions per seconds, that's a direct frequency. So omega you can write, omega will be simply what 2 pi nu you can write, sometime time period is given, then you can write 2 pi by t also. Here sometime frequency is not given rps, they give in terms of rpm, then rps will be simply equal to what rpm by what 60, revolutions per minute is given, you can convert that into rps, then find nu and find omega and you calculate. This is the wheel is rotating initially at rest, now start moving, means its initial angular velocity is what 0, or already it was moving and coming to what rest, stopping, then final angular velocity is what 0, right? Okay. So after doing this, then we have learned two type of circular motion, right? We learned what uniform circular motion, one was uniform and one was what non-uniform, right? What's the difference between them? So in uniform acceleration, we have two acceleration in a circular motion, right? One is called a tangential, suppose moving, this is called a tangential, this is called what a centripetal, right? So net acceleration is what we add these two by vector rule, we get what a c square plus what a t square. So when you talk uniform acceleration, then your a t is directly what 0, this is moving at constant speed, right? So the acceleration in tangential direction which comes due to change in velocity, so that is what directly 0. So only we have one acceleration, net acceleration will be simply what ac only, right now. So total acceleration in case of uniform circular motion is what just centripetal acceleration, which is what mv square by r. Formula also know that your ac is called simply mv square by r and your at is called what rate of change of velocity dv by dt, right? Yes. So uniform is only centripetal acceleration is there, so net direction also what towards the center like this one, because this is not there. But in case of non-uniform, both acceleration are there, so net direction will be somewhere here, this is the direction of what net acceleration, right? So both you have to write if they ask to calculate acceleration. Okay, after uniform, non-uniform, we have learned like dynamic of circular motion. We like learn this vehicle is moving around the circular roads, then what velocity we need to turn what safely, so that we have learned in 3 ways, right? So the topic was like turning around what circular rod, okay? So in this, here we have 3 methods to turn safely. One was like friction alone, you make the rod a rough rod so that you does not skid or slip. So for this we need a minimum velocity, what minimum velocity or safe velocity can travel. So we calculate this one in terms of mu, that came mu rg, this was the formula. Or if you want to turn safely, you can have another method is what banking method. You don't have friction but you can bank the rod. So another method was what banking. In that case the same formula look like what rg into what tan theta, instead of mu becoming what tan theta. Theta is what the angle of banking. Next topic was like we can combine both friction and what banking together. Friction and what banking you put what together. Here very important, I did a small mistake in last lecture. So you put lot of comment there also. So let me do it again. I did a small sign mistake. So what happens, suppose you are turning on a rod which is what banking also there theta and is rough also there. Suppose your body is what here, your vehicle is here, then what are the forces acting on this? First mg straight downward, right? Normal direction always perpendicular to what surface n, right? Friction force will be outward. Again we have 2 cases here. Suppose the vehicle speed is small, then friction force will be what outward, and if speed is what very high, the friction force will be what inward, okay? And this is what your direction of your centripetal force, let's call it what mv square r, and this angle theta, so that angle also theta, you draw with the perpendicular line, this angle also theta. Let's write the component now, okay? Look here, component of n along vertical direction is what n cos theta. Component of normal direction along perpendicular or this along this line is what n cos theta. Similarly component of frictional force along that direction becomes what f sin theta, right? This is the angle theta here. So that should be equal to what mg. First equation was like this one. So in second equation I think I did mistake, so let's check it. Okay, component of this n along this line is what this component is called n sin theta, correct, is equal to what, we have only one force in this direction, along this direction centripetal force we have 2 force, one component f which is called f cos theta plus what mv square by r. So this you can write as n sin theta minus f cos theta is equal to what mv square by what r. So these 2 equations we have now, these you have to solve. So here what you did a replacement of what frictional force. Frictional force is what simply mu into what n, correct. You replace that and then you divide these equations. So I am writing directly. Suppose how it becomes, it becomes n cos theta, then you putting f value, which is what, plus mu into n, and what, sin theta is equal to what, mg, okay, divide by this equation. So how much that coming, this was here, so n sin theta minus again f we are doing mu into n, what, cos theta is equal to divided just them, so it becomes mb square by what, r, right. So what you did here, you took n common and you calculated these things. So okay, so here n you took common everywhere, it get cancelled, so you got cos theta plus mu sin theta upon sin theta minus what, mu cos theta, this was equal to what, r went up, so r into g upon what, v, correct, yes. Now what we doing, we have to calculate safe velocity, right, v we have to calculate, so rearrange this, sorry, this is v square, okay, v square, so v comes how much, that comes here, that comes down, and rg, so answer is coming root rg into what, sin theta minus mu cos theta upon what, cos theta plus mu sin theta, okay. Now everything we divide by what, cos theta, so we get answer in terms of what, tan theta, so this is what, rg, okay. Everything we dividing by what, cos theta, sin by cos, sorry, everything we dividing by what, sin theta, right now, or cos theta, yeah, sorry, we dividing by what, because we have to get answer in terms of what, tan theta, so let's divide everything by what, cos theta, sin by cos becomes what, tan theta here, minus mu, cos by cos is what, gone, okay, here 1 plus mu what, tan theta. So what mistake I did now, I wrote here a sign wrong, that's what's the mistake, while calculating I wrote the sign wrong here, so please, this is the correct formula, okay, please check it, okay. Okay, so this was 3 method of banking. Then here we learned few other things also, like a rotor we have learned. Rotor is what, like a cylinder is there and some body is moving around this, okay, yes. So when you are moving, we need what, speed to keep moving so that it does not fall down. So 4 forces are acting here, right. Friction force is acting what, upward, because sliding downward. mg is what, acting downward, so friction force should be equal to what, mg, and here we are applying what, normal reaction n and centripetal force mv square by r, so normal reaction should be equal to what, mv square r. These 4 forces should be like this one to what, so that you can move safely around that, right. Conical pendulum also I told you, conical pendulum is moving like this one, you have tied with a string and string moving like a circle like that way, okay, yes. So what is the time period of this, so it becomes 2 pi L cos theta by g, all these things I have told you, there should be no problem, okay. Then last topic was our motion in a vertical plane, this was like horizontal. What is the important thing in horizontal, the tension is always constant. When you move a string in a horizontal plane like the string, okay, yes, then the tension the string T is always equal to what, just centripetal force mv square by r, T is equal to what, just mv square by r, this much only, because mg will be perpendicular, so that doesn't come in calculations, but in vertical mg will come calculation. So when a body is moving in a vertical circle, right, we start from here always, then tension first calculate here, tension T, so 3 forces are here, T, mg and what, mv square r, right. So direction changing here when you are moving in circle, so tension at any point, general formula we gives what, mv square by r plus mg cos theta, at any point this is a tension, correct. This theta is with respect to always this line, suppose this is your center, here you are here, this is your angle theta, you are here, then this is your angle theta, you are here, then this is your angle theta, you are here, this is angle, with respect to this vertical line we measure that angle always, right. So also we have learned now that, suppose we have learned 3 conditions here, right. What 3 conditions, suppose when it do oscillation, first condition, right now, oscillation. The oscillation means the particle start from here, it can goes up to this maximum horizontal position this much, and this one both side, like it's oscillating like a simple pendulum. For that the velocity at this point should be what, is more than 0, but should be what, less than or equal to what, root 2gr, that we have learned, right. Till the velocity at this lowest point is in this range, okay, it will oscillate. Then afterward leaving the circle will happen, means your particle start from here and goes, crosses this horizontal position, but it cannot reach up toward that point, it will be somewhere here, and that the string will slack and it will what, break the loop, okay, Yes. So in that case, what should be velocity? The velocity should be root more than root gr, but it should be less than what? 5 gr. Velocity, if it's more than root 2 gr at lowest point, but less than root 5 gr, in that case it will what have condition? Leaving the loop condition. Or you want to complete the loop, then the velocity at lowest point, this should be what? At least equal or more than what? Root 5 gr. Equal or more than root 5 at this point, then it will make a complete loop. So this also you can say in three ways. At least to make a complete loop, velocity at this point should be at least root 5 gr. Then you can say at this point horizontal, suppose you start motion from here, then should be what? Root 3 gr. Or they talk about top, then velocity at this point should be what? Root gr to make a complete loop. Okay. Then also you have learned that at this point the velocity will be maximum. Yes. At this point velocity will be minimum. Yes. Then we say tension. Tension at this point also should be what? Maximum, and tension at that point will be what? Minimum. Right? Yes. Then like same question they also you have done in terms of tension also. Suppose you want to make a complete loop, then what's the minimum tension we need at this point? That was 6 mg. At that point tension could be what? 0 also. Still make a complete loop. Correct? So all these things we have done now, and this was a mistake, so please give attention here. And that's all. So still if you have any doubt, please put your comment, no problem. Okay, I will reply all of them. Thank you so much.